Okay, so it's given that O is the origin. We have A to be the point 1, 3, B negative 2, 1, and P is the variable point given by OP, which is OA plus parameter T, and the direction vector AB. Alright, so we need to calculate first the angle AOB given your answer 200 degrees. So again, we are using the same formula, the formula that we have been taught, that if we were to find the cosine of the interior angle between two vectors, it can be written, for example, A and B. This is just the dot scalar product of A comma B over the magnitude of A multiplied with the magnitude of B. Right, so this is the formula that we're using. And you want to find AOB. So AOB, so if we were to visualize it, it looks something. So this is probably like A, O, B, correct? And so we are using A, vector A and vector B, free vector A and free vector E. Right, so what's OA? So you can see that OA is nothing but the vector 1, 3. Right, OB is nothing but the vector negative 2, 1. Okay, so first one, you need to find the angle AOB. Angle AOB, quickly we can just use the formula, and this is cosine AOB. This will just be the scalar product of OA and OB over the magnitude of OA and OB. Right, and this will give us, if you were to write it out, this will be 1, 3 dot product with negative 2, 1 over square root 10 square root 5, okay, which will be approximately 0.141, right? And therefore AOB will be equals to the cosine inverse of 0.141, which is approximately 82 degrees, because the question asks for us to find it to the nearest degree. Okay, so for next part 2, we need to find the value of T for which OP is perpendicular to AB. Okay, so perpendicular to AB, you know that this should relate you to think about scalar product. So we know that if two vectors are perpendicular, their dot product will give you 0, right? So what we do is we take OP and AB and we scalar product them to each other. So we scalar product them to each other, and what we do is now there's OP and there's OP and there's AB. What is OP? OP, let me use another pen. OP, as we have found earlier, this is equals to, we know that it's the same in the question is OA plus a parameter of T of AB, correct? And what is OA? OA is nothing but 1, 3. Okay, we have a parameter T. I'm just going to put curly. And what's AB? AB, I'm sure you can find it yourself. It's nothing but just OB minus OA. So you have a negative 3 and a negative 2 and negative 2. Okay. Alright. So with that, what about AB? AB, as you found, is a negative 3, negative 2. So if for us to put down the scalar product of OP, okay, scalar product with AB, right? Let me just try to write this nicely. Right, this will be equals to negative 3, negative 2. This is AB. Alright, okay, so OP, right, we can write it another way. We can write it as 1 minus 3t. 3 negative 2, so we can write it as 3 minus 2t, correct? Right, so scalar product, this will give us, okay, we'll put scalar product dot value is 1 minus 3t, 3 minus 2t, right? So with that, what's the scalar product now? We just take a look. Okay, so scalar product, first component multiply with first component, second multiply with second. Okay, we just have very quickly you can see that we end up with some sort of algebraic, linear algebraic equation. 1 minus 3t minus 2, 3 3 minus 2t. Alright, and solving this quickly, I'm just going to get t. You're going to get something negative 9 plus 13t. Right, okay, so if you want this to be 0, now that means you want, right, so the next one, for OP to be perpendicular to AB, right? Okay, what do we need? Okay, we need the dot scalar product to be 0. Okay, so this means that what do we need actually? The scalar product is negative, nothing but negative 9 plus 13t, right? So we just need negative 9 plus 13t to be equals to 0. Alright, so I mean quickly you can see t just equals to 9 over 19. Okay? Okay. Alright, so next one we'll be looking at part 3. Part 3, we need to find the value of t for which the length of projection of OP onto the x-axis is 5 units. Alright, so first we need to know length of projection of OP onto x-axis. OP onto x-axis. OP on the x-axis. So if you visualize, I mean you think about it, it's like I put the x-axis here, alright, then we have an OP, alright, this is the origin, this is P, alright, this is the x-axis. Okay, if you were to take a unit vector along the x-axis very easily, you can just take one vector. So remember, just like what you learned in the lecture question earlier, just take unit vector 1, 0, 0. Okay, oh sorry, 1, 0. Because here we're talking about two-dimensional. Okay, so 1, 0. Let me rewrite this. Just 1, 0. Right, what's OP? OP is the Hall vector earlier on. Right, this is equals to 1 minus 3t and 3 minus 2t. Right, okay, so we want to find the projection of OP onto the x-axis. Right, what is projection OP? So remember, we remember the formula. If we have A, right, then put it onto B, correct? We need to find our length of projection. So the length of projection is like, so if I were to cast a sunlight here, right, this will be the shadow. So this is the length of the projection, right? All we need to do is we're just finding the answer is just A scalar product with the unit vector of B, right? So very quickly, all we need to do is we look at this. Here, this is 1 minus 3t, 3 minus 2t, right? This A here is this function, it's this vector. B here is already a unit vector, right? So dot product with 1, 0, okay, and modulus, so modulus, right? And this will give you modulus of 1 minus 3t. Okay, so give you the modulus of 1 minus 3t. So this is the length of projection of OP onto the x-axis. Alright, in algebraic form we have, parametric form, 1 minus 3t modulus. Right. So back to the question, we want this to be 5 units, right? We want this to be 5 units. What does it mean? It means that we want the length of projection to be 5 units. We want the length of projection to be 5 units. It means that we want modulus 1 minus 3t to be equals to 5 units, right? And this is just a simple modulus, linear modulus equation. You can just solve it quickly. It just means that 1 minus 3t is equals to 5, or negative of 1 minus 3t is equals to 5. Alright, and solving this by yourself, you should get 3t equals to 2. You should get t equals to negative 4 over 3. Okay, so that's the end of PQ question 1.